equation, right? For this case, equation 1, this equation is only valid, right, when one of the principal stress is equal to, or the stress mean is equal to 0. Okay, and the principal, the other two are either both positive or negative. Okay, so either positive means you are both in the tensile, or negative. What do I mean by or negative? Both are negative. If you have your 3D mole circle, now both are in compression. The shear does not matter, positive or negative shear does not matter. When this is the case, right, the stress tau max will be equal to stress mean divided by 2, because stress max is equal to what? Is equal to 0. Are we clear? Okay, so again, sometimes you use stress max, sometimes you use stress mean. But if both your normal stresses are in compression, you use stress mean, because your stress max is equal to 0. Okay, now we are now going to look into another situation. Okay, and the situation is such. Okay, so an alternative condition. So the alternate condition is such that tau max is equal to half the absolute value of stress max minus by stress mean. Okay, so I'm going to call this my equation 2. Now for this case, okay, stress max and stress mean cannot be equal to what? 0. Okay, it cannot be equal to what? 0 at all. So if we now look at a loading condition like what we had before, so this is our X, Y, and Z. So now for this case, we have our loading situation, okay, where we have stress X, shear XY. Okay, so for this case, what we can have is this. Okay, what we can have is this. We can have stress X is positive, okay, and stress Y can be negative or equal to 0, or you can have stress X is negative and stress Y can be positive or equal to 0. So when this is the case, what's going to happen? Okay, so now we are going to look at a situation now. Okay, now we're going to look at a situation now, okay, where we have, this is our point X, this is our point Y, and this is our point Z. So now I'm going to sketch this situation out. Okay, now we are we're going to get this situation out. So now we have our mole circle. Okay. So this is your normal stress. This is your shearing stress going clockwise and anti-clockwise. And then this is your stress X. And you know that this line is your stress Y and your stress Z. And we know that point Z is here because point Z have zero normal stress and zero shearing stress. And then we have our shearing stress. Okay, so from here, anti-clockwise, so we know that this is your point X. Over here, this is your point Y. Okay, and then we draw a straight line. Right? Then you draw your 3D mole circle now. So this is your one circle. Now, for this case, you realize that the XY plane is the biggest circle. Okay? And it is in a coincidence, if you draw this in 2D mole circle, this is also going to be the biggest circle. Right? But you have to be careful. You cannot just ignore 3D because if you have a situation like this, ignoring 3D, you're done. But for this case, you can ignore it. Okay, so whether you can or cannot ignore it, the best is just sketch your 3D mole circle. You don't want to be confused. Okay, so now if I were to sketch a 3D mole circle, now in your exam, I will emphasize that you have to sketch 3D mole circle, so you have to draw 3 circles. Okay, if you're not, we will deduct mark. So this is for your YZ plane. And then the last circle over here this is now for your XZ plane. Okay. So now something is different now. Yes or no? The expression is different now. Okay, because your stress mean now is no more equal to 0. All right. So let me go into that mode again. So we know that this is your stress average. Okay. So you can see from here, you can see that the XY plane or tau max is equal to tau max in the XY plane, right? You can see that. So the next thing you have to calculate now, so this is your stress max. Okay. Over here, this is your what? Stress mean. Okay. So we know that stress max and stress mean is equal to stress average plus or minus by your R, right? Okay. So we know that stress average. So before we go on, we are going to focus on the XY plane. Because the XY plane right? It generates the biggest circle, right? The biggest circle is the most important circle. Okay, it generates the biggest what? Circle. Okay. So when this is the case, you calculate your stress average of your XY plane, which is stress X plus by stress Y divided by 2. Okay. And then for this case, right, we can also now calculate your one. Yeah, it's correct. You can also calculate your radius, which is your tau max xy. Okay. So for this case, this will be equal to, again, you have your stress x minus by stress y, right? Divided by 2 squared plus by the shear xy squared. Okay. So from here, we have to apply that stress max is equal to half the absolute value of stress max minus by the stress mean, right? Because now stress mean is no more equal to 0. Okay. So we know that using this formula over here, right? We know that stress max is equal to stress x plus by stress y divided by 2 plus, okay, by this value over here, right? And then we know that stress mean will be equal to, again, this entire magnitude. All you need to do is to change a minus sign, right? All we need to do is now to change a minus sign down here, right? So tau max now is equal to half the absolute value of stress max minus by stress mean. So this will be equal to half, right? So stress max, I'm going to put this entire thing in, right? And then we are going to minus, right, the other value, right? And square bracket and absolute, right? So when you remove the bracket, you can get rid of here, you can get rid of here. Minus minus will become plus, so this will be equal to half square bracket 2, and then no need square. It's okay, I put a square. So this will be equal to stress x minus by stress y divided by 2 squared plus by shear xy squared. And then when you cancel, this will be equal to square root of stress x minus by stress y divided by 2 squared plus by shear xy squared. This is equal to your tau max. So this expression over here must be less than or equal to your tau max experimental. Okay. So you can see like the tau max over here, right, is different from the one, right? It's different from the one over here, right? It's different because over here you have 0 down here already. Whereas for here, it's not equal to 0. This is your stress mean. But when you work out the value based on these two conditions, right? If you look at this expression over here, and you look at this expression over here, 3D mole circle, hold on. Where is our, and you look at our, sorry, wrong page. When you look at the expression over here, and when you look at the other expression, right, it's not the same. You can see that, right? Right. So the one before, right, for this case over here, is where stress mean is equal to 0. So the expression will be half stress expression 0. If not, right, when stress mean is not equal to 0, then your expression changes. You can see over here. So two different conditions. Right, what I'm going to do is I'm going to stop here. Tomorrow, okay, I'm going to go through this example over here. Now, this example is not that bad. Okay, I'm going to have this example paste over here. The good thing about this example is, let's quickly talk about this. So if there is your axial load, this is your torque, and this is your moment. So they already give you the moment, the torque, and the axial force. We have to determine where failure. Okay, so tomorrow we are going. This is a important problem. Okay, we're going to look at maximum shearing stress criteria. Okay, thank you for your time. I'll see you guys tomorrow. Bye. I have questions. You have questions? Stay behind. Okay, I can answer them. If not, you can go. See you guys tomorrow. Then. Bye.